Hi Year 8, this is the fourth lesson for our topic of equations. In this lesson we're going to look at equations in real life. So in our equations journey so far, we've reviewed one-step equations and two-step equations. We've learned all about pronumerals on both sides, and then we've done some harder equations with fractions and harder equations with brackets. So we can use equations to solve word problems. This is the method. Firstly, we have to define a variable. Then we set up the equation. We solve the equation, and then we interpret the answer. Here's our first example. Kim thinks of a number. If she doubles the number and subtracts it from 14, the result is 10. What is the number? So we're going to start by defining our variable. Let the number be n. We don't have to choose n, we can choose any pronumeral. Now we need to set up an equation. What's wrong with this? Let's read it again. If she doubles the number, that's 2n, and subtracts it from 14, this is back the front, isn't it? So it's really important with word problems that you read them carefully. In fact, we should have this. 14 take away 2n is equal to 10. Now we need to solve the equation. It's a two-step equation. We need to move this 14 over the other side. It's a plus 14, it comes over as a minus 14. And now we need to rewrite it. Minus 2n is equal to minus 4. Now what we're going to do here is divide both sides by this negative 2. So I'm going to take it over here as a divide by negative 2. You can even use your calculator for that if you want to. N is equal to, what's this? Negative 4 divided by negative 2 is 2. So let's interpret the answer. Therefore, the number is 2. Here's our second example. Henry is 5 years older than his brother Sam. The sum of their ages is 51. How old is Henry? Let's start by defining our variable. Let Henry's age be h. Therefore, Sam must be h minus 5. Does that make sense to you? Because Henry is older than Sam by 5 years. Now the next bit in the question says that the sum of their ages is 51, so let's set up our equation. H plus h minus 5 is equal to 51. Now we need to solve our equation. 2h minus 5 equals 51. Take the 5 over, becomes positive 5. 2h is equal to 56. Divide both sides by 2. H is equal to 28. Now, we haven't finished, we've got to interpret the answer. Therefore, Henry is 28. Here's our third example. An isosceles triangle has a perimeter of 15 centimeters. The two equal sides are twice as long as the base side. What are the lengths of the sides? So, a diagram is a really good idea here. Here's an isosceles triangle, and these dashes indicate that these are the equal sides. Let's define a pronumeral. Let the length of the base side be x. That means that these two sides must be 2x. Now let's set up an equation. It says the perimeter is 15 centimeters, so that's x plus 2x must equal 15. Let's tidy this up. This is 5x equals 15. Divide both sides by 5 and x is equal to 3 centimeters. Now look up here at the question. It asks us what the lengths of the sides are. Doesn't just ask us what x is. So we have to give all three sides. The sides measure 3 centimeters, 6 centimeters, and 6 centimeters. Okay, moving on to formulas. Sometimes equations are formed after we substitute into formulas. Here's an example. Suppose the area of a rectangle is 55 meters squared and we know that the length is 8 meters. What is the breadth of the rectangle? So the formula for the area of a rectangle is length times breadth. Let's substitute in the numbers that we know. The area is 55, so that goes in there. The length is 8. That goes in here. We've got an equation. Can you see that? Let's solve for b. We want to get rid of this 8. It's a times by 8, so it's going to come over as a divide by 8. Now in this case, I'm going to use this divide by sign because this is a real life situation and a fraction's not really going to be very useful to me. I want a decimal answer. Just doing that on the calculator, I get 6.875 meters. I might even like to abbreviate that to 1 or 2 decimal places. Here's our second example. Jeremy measures the area of a trapezium and finds that it is 400 centimeters squared. He knows that the parallel sides measure 10 centimeters and 15 centimeters. What is the height of the trapezium? So here's the formula. H is the height of the trapezium, A and B are the parallel sides. So 10 and 15 go in here. Order's not important because they're being added together. And this is the area, so 400 goes in here. Here's our equation. We want to get H by itself. Let's start by moving this divide by 2. It's coming over as the times. Now at the same time, I'm sneakily going to add these two together. So I get 800 is equal to H times 25. Let's see if that makes sense to you. 2 times 400 is 800. 10 plus 15 is 25. Finally, let's get rid of this times 25. We're going to divide by 25. 800 divided by 25 is 32 centimeters. Now you could be given a question that has a formula that you might not have seen before, like this one. This formula converts a temperature of Celsius to a temperature of Fahrenheit. F is equal to 9C over 5 plus 32. Now let's start off by just doing a straight substitution into the formula before we look at an equation. Convert a temperature of 40 degrees Celsius to Fahrenheit. So we're going to put the 40 in here. Don't forget there's a times between the 9 and the C. We can just put that in the calculator. 9 times 40 divided 5 plus 32. That's equal to 104 degrees Fahrenheit. Now can you see how that wasn't an equation? It was just a straight substitution, and that's because the thing that we wanted, which was Fahrenheit, was out the front all by itself. This is called the subject of the formula. Now let's have a look what happens when we convert a temperature of 50 degrees Fahrenheit to Celsius. Instead of substituting in here, we're substituting in here. Can you see how that's an equation? Now we need to undo the 5 and the 9 and the plus 32 in order to get C by itself. Let's start by moving this plus 32. So it comes over as minus 32. Rewriting it, we get 18 is equal to 9C over 5. And then moving this divide by 5, we get times by 5. Rewriting again, we get 90 is equal to 9 times C. Do you know what the answer is? We can solve that by inspection, can't we? 9 times 10 is 90. So C is equal to 10 degrees Celsius. Okay, that's the end of this lesson. So in our last lesson for equations, we're going to look at quadratic equations.